So now a long time ago, I made videos with these diagrams, went into more detail than I will in this one, but I didn't have any video ideas, so I figured I would do a quick review of this. When it comes to parallel LEDs, you want to give each one their own protective resistor right there. So you got a voltage source, the LED has its own resistor from both ends of the power source right there, as does this one over here. So whatever current is flowing through that resistor and LED does not impact the current that flows through that resistor and LED. The power source just has to provide the total current that is flowing for both of them. And the reason why you definitely want to do this is that LEDs do not necessarily share current equally. In fact, there's a good chance they won't. If they're different colors, like you got red there, blue there, the red one will take all the current. So if you try to set a resistor value based on LEDs sharing the current, they might not. You might have one that takes it all, and it might burn out right away. Now we're going to look at LEDs sharing current. These are probably red LEDs. In fact, I did write a note there. We have red LEDs. They drop about 2 volts. The red indicator LEDs, the little ones that are commonly involved in kits and so forth. So if we have a 12 volt power supply, let's say, that is a lot of voltage for lighting an LED. You can get 5 of them in series and light all 5 of them with just one current setting resistor. So with 12 volts, if we have 5 series red LEDs, each one's going to drop about 2 volts. So they're going to drop about 10 out of that 12 volts right there, leaving about 2 volts. So if it's a 150 ohm resistor that's got the rest of that voltage, I did the math a long time ago, I assume this is correct, we got about 13.3 milliamps of current that is going to flow through this circuit right there. So now in the last scene we looked at red LEDs in series. Now we're going to look at blue LEDs in series. Blue LEDs, the indicator LEDs that are commonly included in kits, they fit in the breadboards nicely. We have about 3 volts that each one of them drops. Takes about 3 volts across them before they'll start conducting current. Once they start conducting current, 3 volts out of the supply voltage builds up across the LED. So if we put them in series, each one's going to build up about 3 volts. So with 3 of them in series, they're going to build up about 9 volts. So 12 with 9 volts dropped by the LEDs is going to leave about 3 volts across the current setting resistor right there. So we're going to use a 1000 ohm resistor. 3 volts across the resistor divided by 1000 ohms is 0.003 amps or 3 milliamps right there. Blue LEDs get pretty bright at low current, so 3 milliamps is plenty to light them pretty brightly. And the last diagram on this sheet here, we have a couple of fixed value resistors in series with the supply voltage across them. 12 volt supply, that's the positive terminal, negative terminal. We consider ground or 0 volts, 12 volt difference right there. So since there's 2000 ohms of resistance total between those 2 points, we'll have 12 volts divided by 2000 ohms, 0.006 amps or 6 milliamps of current. If you have 6 milliamps of current going through a 1000 ohm resistor, it will have 6 volts across it. We could measure that, and I probably did in the longer video that I did where we did this. But in any case, in relationship to ground, which is usually where a load or something else is referencing its voltage to, 0 volts there, we will have 6 volts higher at this point right there. So if it draws current, that's going to throw the voltage off. You want something that doesn't really draw any current. But in any case, it'll be a 6 volt reference in relationship to ground there.